This is Advent of Code day 18 in OCaml in 3, 2, 1, go. Boiling boulders. You and the elephants finally reach fresh air. You've emerged near the base of a large volcano that seems to be actively erupting. Fortunately, the lava seems to be flowing away from you and toward the ocean. Bits of lava are still being ejected toward you, so you're sheltering in the cavern exit a little bit longer. Outside the cave, you can see the lava landing in a pond, hear it loudly hissing as it solidifies. Depending on the specific compounds in the lava and speed at which it cools, it might be forming obsidian. The cooling rate should be based on the surface area of the lava droplets. So you take a quick scan of the droplet as it flies past you, your puzzle input. Because of how quickly the lava is moving, the scan isn't very good. Its resolution is quite low, and as a result, it approximates the shapes of the lava droplet with 1 by 1 by 1 cubes on a 3D grid, each given as its XYZ position. To approximate the surface area, count the number of sides of each cube that are not immediately adjacent to another cube. So if your scan were only 2 adjacent cubes, like 1, 1, 1 and 2, 1, 1, each cube would have a single side covered and 5 sides exposed, a total surface area of 10 sides. It's total surface area of your scanned lava droplet. All right. Let parse input equals string dot split lines. Input list dot iter on s. ABC, XYZ, XYZ. Map. Let droplets parse input in. Okay. So how does this work? So each cube has 6 sides. And then, let's see, what is the analog in? In 2 dimensions. So like if this is 0, 0, 1, 0, 1, 1, 0, 1, then, oh, really this is like, it's really like the square is here, and so you can kind of think of it as like plus 0.5 in a direction, that really this is like 0, or this is like 0.5, 0, and this is 0, 0.5, and then like this is 0, negative 0.5. And so in 3 dimensions, Yeah, you basically, okay, because it should be 6. And so you try, for each of the 3 dimensions, you add half. I hope that works. Um, 24, the droplets. Okay, perfect. I don't want to do that. I do want decimals. Okay. Let hash set, let points equal, damn it, x, y, z, 0.3, let create x, y, z equals x, y, z, 0.3 dot equals hash set dot create module 0.3 in list dot iter droplets hash set dot length points fun point let x, y, z equals point in hash set dot add points dot create x minus 5 y z What's wrong? Oh, up here. Oh my God. Oh. Come on, get under 10 minutes. Damn it. Oh, come on. All right, I have to get my cookie. That's a bummer. All right, we are back in business. No, too high. Oh, okay, of course. I want how many arcs are exposed. Hash table int dot hash table. Faces equals, and then let anchor faces equals point equals in hash table dot find. Oh, I'll do this. If hash table dot mem point, then hash table dot add accent point one faces, else let count equals hash table dot find xn faces point in hash table dot add ignore add faces count plus one. Key point data. Key. Anchor faces. In let exposed equals hash table dot count faces f fun c equals one in exposed. What, again? None. Some count. Does it not overwrite? Oh. Change. Set. Okay. Mm-hmm. 4,500. Yay. All right, something seems off about your calculation. The cooling rate depends on exterior surface area, but your calculation also included the surface area of air pockets trapped in the lava droplet. Instead, consider only cube sides that can be reached by the water and steam as the lava droplet tumbles into the pond. The steam will expand to reach as much as possible, completely displacing any air on the outside of the lava droplet. Whoa, okay. Exterior surface area of your scan droplets. $2,781. Okay, how do I find that out? All right, so it looks like it's all between 0 and 20. Okay, yeah, I can do this. Let let all chords equals list dot concat map droplets in let min point equals list min all chords -1 max +1 in let point let air let droplets equals hash set dot of list droplets in let air equals hash set dot create hash set dot create module 0.3 in let q let front q create of list point dot create min point in while not q dot empty is empty q do done. Okay, and so now I want to do hash set dot add air let point equals q dot pop. What? Oh my god, why is their website is so slow? And then it has, I don't care about this stuff. Get. Okay, weird. Wait, how do I don't understand this queue interface. Why is this so slow? What the heck? Is it just not loading stuff? Okay, enqueue and dequeue. Add air point. maybe at maybe enqueue neighbor n equals if not hash set dot mem air n and not hash set mem what okay mem droplets n and min point less than equal n dot x and n dot x less than equal max point and then q in q n in maybe in q point maybe in q neighbor module 0.3 let total points equals max point minus min point 1 let side equals max point minus min point plus 1 in side times side let interior points equals total points minus length droplets minus hash set dot length air in print part 2. I just want to see how many points there are. This isn't the answer though. Okay, weird. Aha. $64. If it's not in air and it's not in droplets, print S. Added to air. I'm so confused. What? 10, 30, 40. Output. Let's collect some output. Output, sort, unique. Yeah, what? Print. What do I want to do? Hash. Set.add air. Set.mem air. I'm so confused. What the? Oh. So we add 40, 20, 30, and then we're including 50. Oh. Wait. Forty, 10, 40, 50, 10, 40, 40, 20, 40, 40, 10, 50, 50, 10, 30. Does this eventually end? What scene equals hash set dot in. I'm very, very confused. Okay. So we have our set of air. Printf number of droplets. Hash length. Printf min max. Okay, what I actually want to do is this. If, then, hash table or hash set at hash set dot add air n q dot enq n. Okay. I don't know why I struggled so much with this. Dang it, that's a lot. I don't know what that just was. Okay, that is a lot of interior points. Hash set dot iter droplets. Decker face, if not. Oops. Hash set iter if by air. Let outside faces if hash set air. Point. $58. 2558. Oh my God, that one is a disaster. That one did not go well. All right, how this one worked. We have a bunch of points, and we basically wanted to count how many of their faces were exposed, and basically not count faces that were touching the face of another thing. So the way I did that is basically like, if here's a grid, and they're 3D points. Here's a grid, so if here's 0, 0, and here's like 1, 0, then like then sort of like the block is this area, and so the face is at 0.50, and the face of the neighbor is also at 0.50. So I scan all my points, multiply them by 10, and then I basically create a set of faces, which is the points plus 5 in each of the 6 directions, adding the X, Y, and Z. And then I just count how many of the faces have are only show up once, because those are the exposed ones. Then for part 2, it turns out that like this structure actually has some holes in it, or there's air inside, yeah, there's air inside, and so we only want to count the faces that are actually really exposed to the air. And so the way I do this is I basically get like the min and max coordinates of all the points, and then I create a box around them, and then I just do a flood fill to get the set of all the points around them. And it just wasn't working, and I was very confused. Let's see, let's add this. 18. Oops. This is December 18th, 2022 solution. So this was just bizarre. I have a queue of neighbors that starts with 1 corner, and then I add 10 and minus 10s to make sure that there's like air all around that I can, use to get to all the points. So I have a queue of points that I haven't considered, and then I maybe enqueue a neighbor. And I guess the issue is I wouldn't add it to the set of air until I used it in the queue. And so things would just show up in the queue millions of times. Yeah, I guess that's the issue. Ugh. So while the queue isn't empty, I get a point, I add it to the set of air, and then I try to maybe enqueue all of its 3D neighbors. And when I enqueue the neighbors, I check if it's like in bounds of the min and max point, and that it's not a droplet. And if it's in the bounds and it's not a droplet, I add it to, and we haven't seen it already, then we add it to the set of things we've seen, and then we enqueue it. And basically, the difference was between this, which runs very fast, and this, which does not finish. which I don't entirely understand. Like it should still finish soon. Weird. Okay, well, I lost a lot of time to that. That was a poor performance. So then that gets all of the air points, and then I basically do what I did for part 1 again, but now I only increment the faces if they're by air. And so then I have to pass in both the face, the point that represents the face, and also the neighboring point. And if the neighboring point is in air, then I add the face. And now this is just, I can just count how many faces were exposed and print that out. So that is day 18.